So the launch for Turin is not just a launch for Turin, it's also an event for developers to connect with startup companies and, well, just companies looking to hoover up talent, whatever you want to think of it as. But there are AI luminaries that are speaking here, offering insight into how they run their startups and their products and interesting things that are happening, and a lot of customers that are using the MI300X or MI210 or other AMD products, server products. So this is not just a server launch, this is also an opportunity to say, hey, this is how you can use the products effectively. These are the things that are available in the market right now. It's not just Oracle and Lenovo and Dell that are offering their systems in the cloud, but it's also a lot of other smaller providers. TensorWave. Take a look at TensorWave. AMD had a contest where you could enter to win, and they flew some folks out here to look at what they had developed using different stacks. It was like a hackathon from AMD, which is really interesting. AMD's executives were keen to tout the improvements for ROCm. They still have a long road ahead, but the trajectory and the acceleration on that road, I mean, they're moving faster than the ground is changing underneath them. And so I think that speaks well of AMD's future in this market and the opportunity that they have and their partners, because it's, a lot of the time folks will look at it and say, well, but what's your answer to CUDA? And I need something to be able to run CUDA on not an NVIDIA GPU. But here you have enterprise customers, not just Microsoft, but others as well, that are running their AI workloads for customers, and the customers don't care what GPU they have that they're running, because they're not really exposed to the framework that's actually running on the GPUs. And this event shows that. And this is also really AMD is not trying to control the situation so methodically that it's just like, hey, these are folks that use AMD products, let's get them together in a room and just let them talk amongst themselves. AMD is not controlling the messaging and not controlling the marketing. They're just saying, let's come up with some products that we think solve a lot of problems and then let people use them. Hey, there's a jet. The other big thing with the reveal here is the networking side of things. Software-defined networking and putting all of that together, and more software-defined networking offload. 400 gigabit, these networks demand, dual bonded 400 gigabit and beyond. NVIDIA is working on 1.6 terabit, so 400 gig, 800 gig, dual 800 gig channels, 1.6 terabits. AMD doesn't seem to be far behind just in raw throughput, but what AMD has with Pensando and the software stack looks pretty solid. These are networking cards that have a packet processing engine on them, but AMD also has another networking product that includes both the P4 packet processor as well as the GPU compute capability. So if you wanted to combine AI and a packet processor, that's an option. And it's really interesting because there are several products that have popped up in the market that seem to address this need of, well, let's combine AI and packet processing. Almost like there's a lot of startup founders and visionaries that have ideas about how products that combine AI and packet processing might be part of the wave of the future. AMD also extended trusted computing on the networking side of things so that you could do trusted computing enclaves and whatever that means, from the switch all the way down to the CPU. What it really means is that the data is encrypted at every level. Look, software's going to have bugs, and bad people are going to figure out how to exploit the bugs, and bad people figuring out how to exploit the bugs when they get through and they're able to pull the data from the system, or when they get through the bugs unexpectedly. You want them to find an unencrypted cache of data, or do you want them to find an encrypted cache of data? So what trusted computing can bring to the table is, well, even if the hackers find a bug, or even if the data is lost at the network layer or at the switch layer, or some other compromised system is trying to bring down another system, trusted computing means that no, the information that was accessed surreptitiously was actually encrypted, and in a low overhead kind of a way. So we're not applying a software decode step. This is all just sort of handled for us in the hardware, because we don't want the overhead of having to deal with that. I mean, it's always been a trade-off between security and convenience, right? But if you build the security in, then if it is compromised in some way, you should still get the security benefit, but you no longer have the performance penalty because you've offloaded the performance penalty to other dedicated hardware at every level of the stack. And that is what trusted computing from AMD promises to be, with as little proprietary stuff as possible. I think because of AMD's involvement in open compute and the fact that Meta, Amazon, you got all the open compute participants that are working on this as well. I think there is actually a legit shot at this being an industry standard for this kind of trusted computing, confidential computing type of approach to the security problem, because it's not just AMD. This is sort of what Open Compute members have said. We have this need, we think this would probably fit within it, and you see some of the extensions to Ethernet necessary for that in some of the pre-published stuff for Ultra Ethernet. That was another thing that we saw at this event, is Ultra Ethernet, and Ultra Ethernet, like extending Ethernet. We want to use the 400 gig interface, the 800 gig interface with the Ethernet that we've come to know and love, because we know that that'll work across data centers. We know that that'll let us bring up 100,000 GPU AI clusters. We know that that's going to be the next generation compute that we need. And so Ultra Ethernet being a part of these AI things, part of this conversation, is interesting. Now, there's not the big reveal. Ultra Ethernet is not really out yet, but it's coming. Open Compute is just around the corner. I really like that this is an AI/developer event as well as a platform launch. I think combining those two things makes a lot of sense, and is a really interesting way to approach innovation in this space. Software developers, entrepreneurs, founders, billionaires funding all this madness. Also had a chance to ask Mike Clark some questions about the Zen 5 cores that we see in server. One of the things, if you notice in my benchmarks, is that the performance uplift from SMT is significant. 192 cores, 384 threads per socket. We've never had a generation of CPUs from any vendor with this much of a performance benefit from SMT. x86 is a messy, complicated instruction. It is computationally expensive to deal with the variable instruction length, and yet AMD is able to pull out a win here. They're able to pull out ahead, not just in terms of raw performance, but also in performance per watt across any platform. The CPU architecture that are in this 100 core plus server workload type CPU comparison benchmarks that we have. So with all that in mind, I asked Mike Clark a few questions like, so tell me about SMT.
Mike Clark, lead architect for the cores here at AMD, aka Zen Daddy. Yeah, happy to be at this great event, happy to finally get this product out. It's always great. It takes so long, it feels like, from high level design to finished product, so it's great.
I think SMT is widely misunderstood, and it actually is a surprising amount of performance uplift. Like when we talk about multi-threading, it's like, oh, one core, but on Zen 5, it is specifically way different than it has been on any generation of any processor from any company previously. You really do get a lot more performance from the SMT thread than you have ever.
Great.
So.
No, I'm glad to hear that. I mean, we do, consider everything we do sort of evolutionary. We're always trying to make it better. Also agree that SMT seems to be a little misunderstood as far as, it brings a lot of value. It's one of our best perf per watt, perf per area features, but it has, implementation does matter, and we have been trying to make sure we provide good, fair performance to both threads across the generations, and there can be, quirks in that behavior that we haven't anticipated, but we continually, try to innovate and make it better over time. And I'm glad to see that you're seeing the results of that on Zen 5.
Yeah, would you go so far as to say that with the engineering you've put into SMT that now it's becoming a significant competitive differentiator for AMD?
I do. I think, like I said, as we continue to make these cores, we have to make them bigger to try to find ILP for the single threaded core case, because we always want to have a strong single thread. But I mean, when you end up with, with Zen 5, we have 448 instructions in flight. You get a L3 miss out the system, there's not much you can do. And having another thread there that you can now dynamically let it get some work done while you're waiting for those misses that are going to go to the system just provides, that uplift. Just one of the many ways that it can provide uplift over time. Maybe, hopefully, an easy way to understand.
For my benchmarks, it seemed like the operating system was struggling a little bit less with loading and unloading threads, because I think that's probably a really big operation, because you got to save all the registers, put them on the stack, and with SMT, it's like, oh, it can just live there for a little while.
yeah, they can just sit there and chill, and we've also, that's another place we've innovated is sort of when they're in that holding pattern, being able to let the other thread really boost up and use the resources of the machine. So,
Cool.
And then when they're ready to go again, we can get back into throughput mode.
Cool. Is there anything else you can think of that would be useful or fun to talk about, or just like, because it seems like there's a lot of changes in the geometry of the floor plan around all of the Uncore stuff to just keep everything fed. It's very well balanced, even over Zen 4. It's a pretty big improvement.
Oh, great! I'm glad to hear that. I mean, it's definitely, as we continue to, make things bigger, you grow caches, we grow the complex. That naturally adds latency. We try to use a technology move to kind of bring things closer together to kind of hide that latency, but there's no getting around that, trading off larger structures can add latency. And so we work really hard to that was even the reason for the name Zen and the balance point. So we're constantly focused on trying to make sure we deliver a balanced design. But there's so many workloads in the world. It's a very complicated problem to try to make everybody happy.
Do you want to talk about any of the encryption stuff, like end-to-end encryption, or features that enable? It's like the encryption is moving out of just being a core function where everything is secure in the CPU, but now it's secure even from the Pensando stuff. It sounded like all the way up to the network switch.
Yeah, I mean, being able to have those dedicated accelerators to do some of the work and let the CPUs do what they're, maybe better at, or just distributing the work out so you get more work done over time is, we look at that stuff all the time, but we want the CPU to be, best in class at its workload. So we work hard at, even for encryption, making sure we can, we double the bandwidth out of the data cache to feed that vector unit, and making sure we're balanced and we don't over-design one thing and we don't have the ability to really drive it.
Has anybody, did you have any answers for questions that no one has asked you yet that you were like, I'm really hoping somebody asks about this?
Yeah, really not, I mean.
So check these boards out. They're breakout boards for Turin. This is the smallest possible motherboard you can get that actually gives you all 128 PCIe lanes, well, actually 128 plus 8 PCIe lanes, plus your baseband management controller, plus even the USB breakout in the corner. This is the single and dual socket variant. And look at how tightly they had to pack in the DIMMs and how close to the edge of the PCB it is. This is a ridiculous amount of engineering, but this example is available to AMD partners so that they can implement their own designs based on this. And yes, this will fit in a 19-inch rack, and this is a 2 DIMM per channel design. We also heard on stage the product cadence, 18 to 24 months. So we're probably a couple of years out for Zen 6, but boy, Zen 6 looks like it is going to have enormous shoulders to stand on when that time comes. Look at everything in San Francisco, with the exception of the jets that are flying around. I'm signing out, and I'll see you later. If you have any questions or you want to hang out in the forum, I'll see you there. All right.